Okay, here I am at I'm at Blast, and what we want is we want nucleotide blast. And what I want to put in here is the gene. Now, the one I'm demonstrating you is the last one on that config. You have yours. So what you need to do is do what I'm doing here, and you need to find that gene. Now, I have it in here as something like, last gene LG. So I'm going to open that, and so I have this one called last gene LG. Now I'm going to leave this mostly the same, but I'm going to make sure that here I have green sea turtle, and you can just type in green sea turtle. There is a more technical name for it, but the system is actually smart enough that if you type in green sea turtle, it actually will use the common name instead of the technical name. So, but that's the one you want. You want green sea turtle, and you want to compare your gene. Now mine was the last gene on the Lonesome George config. Yours is one of the earlier ones. And mine is also pretty large. Yours probably is smaller. Some of you have one. I think there's one that's larger than this one. But this will give you some idea of how long it's going to take to search. So I'm going to stick it first with highly similar. And I'm going to go blast. And we're going to sit here and I'm going to search my config against green sea turtle. And we'll wait a few seconds. It should come up reasonably quick. Maybe 30 seconds. At the most. Here we go. Yes. Now what it comes back with, it's basically telling me what my gene is. And the one that it comes up closest, it's a zinc finger protein, but that's actually not the one. I'm going to look at, I need a good E value. Actually, all of these are just tremendous E values. So there are pieces in here that are common to many genes. So what we want to do is we want to find one that has a high percent identity. And these in the 97% range look good. Of course, there's a small piece that's really identical, essentially, with something else. But actually, it's these here. Here it says tube 1, and that is what the gene is. The gene is tube 1, and so I have 3 different mRNAs to choose from. Each of these is slightly different because they are spliced. And that's the whole idea. So you might have to look at all 3, but generally here is our gene, and so I can just go to one of these. Actually, you probably should go to each one and just pick the longest one, and that'll probably be the one you use. So if X1, X2, or X3, whichever one includes the most exons, is the one you use. So I'm just going to go with the second one here. And we're going to go get this thing. So I need the FASTA for this. So here it is, and I'm going to download that file as a FASTA. Alright, and here it is as sequence 6. It says show in folder. Alright, your system will probably be different, but I'm going to rename this thing first, and I'm going to call it GST for green sea turtle tube 1, because that was the name of the actual gene that we are talking about. So we're actually looking at the tube 1 gene in the Lonesome George sequence, and I now have the green sea turtle sequence mRNA. And so since it's already an mRNA, it's going to show me where the exons are, the pieces I'm actually interested in. So what I'm going to do is I'm going to put this out here. And so we have GST tube 1, and we're going to compare it to our Lonesome George last gene. So I'm going to compare this to this, and of course I'm going to do that with a dot plot. Alright, so let's do dot plot, and let's go get, let's make the first one the Lonesome George. So it's Lonesome George last gene LG. Alright, and so that would be the sequence that I gave you. And then we're going to compare that to, I think it was GST. Oh, I have it already, and I'd already downloaded it. Let's see. Let's get the one that I told you though. I've of course done this several times here. Which one did I give you? It was called I did it with humans too, just to see what it looked like. That's on here. GST, nope. Green sea turtle, nope. It was something tube 1. I remember that. Green sea turtle tube 1. I don't think that's the one I actually downloaded because I think I said GST. But that is it. Green sea turtle tube 1 fast day. So it's I had done it earlier. So let's compare these two. It's going to be the same one. And then we'll go next. And of course I'm going to do this, and let's lower that a bit. Let's go down to 85% or something just to start, and let's see what we get. There we go. And as you can see, it lines up really, really well. All right, now these gaps here are where the ends are. There are some unknown pieces. These breaks are essentially where we're going to find. Actually, this looks like genomic sequence. Maybe that's why I should go find that original, because this is genomic. Now, how do I know this is genomic? The exons would be, the introns would be very large. We should see larger gaps here. So I'm kind of glad I did this, because this is what it looks like when you compare the genomic sequences of the two. I didn't realize I had done that. So the genomic sequences are like this. Realize if you have ends, you're going to have these big gaps here. But you should have some of these big gaps, but with fuzzy stuff around them, where the introns are. And since I don't have that, that means that I'm comparing the two genomic sequences, not the mRNA to the from green sea turtle to the thing. So I'm actually glad I made that mistake to show you that. All right, so let's go. What did I name that thing? It was Lonesome George and GST Tube 1. Okay, got to remember that. All right, so let's do that again. All right, and I'm going to go, and we're going to go here to desktop. Yes, and we're going to get the last gene. Come on. Last gene right there, that one. And then we're going to go, what was it? GST. I do not see it. It's GST. I do not see this. Oh, I'm in the wrong folder. That's why. GST tube 1. There it is. Isn't that right? GST tube 1. Yes. All right. So that's the one we want. Next. All right, and again, let's do that. Now it's here. Let's go down. Let's go 80%. Let's see what that does. There we go. Okay, now this is what you should see. You should see something like this. So this one is the mRNA, and this is Lonesome George going left and right. So here are your gaps. All right, where the ends are, and that could be a problem if you have ends. We might miss a piece, but here are your exons, and the regions in between are your introns. So the introns don't code for anything. These are the pieces. So the piece between here and here along this sequence got spliced out. The piece that was kept was the piece that's between here and here. So realize exons are actually tiny compared to your introns. So the piece that got cut out is between here and here. The piece that got used is between here and here. So in this particular gene, there is lots of splicing. Hopefully yours doesn't have quite so much splicing. But of course, what do? You go look at this sequence. You go see. I clicked on this, and and then we can find this piece right here, and that would be your intron. You would have to search in this region in here for the splice site, find a reasonable piece that meets the criteria for a splice site in this area, and say that that's the splice site. And I will tell you it's very inaccurate. If you just meet the criteria, I'll give you credit. So you say, okay, here is a piece, this is the piece I think is an exon, And I think if you meet the criteria for the splicing site, which this might meet it right there, I think, then yeah, this is the beginning of my exon, and then you go to the end, you meet the criteria there, you go, that's the end of my exon, the rest of it is intron. So you need to identify what? You need to identify the exons. We really don't care that much about the introns. We do care about the exons, of course, and so that's what you're going to be doing in the assignment. You're going to take this one, and then this one, and then this one, and at the edges you're going to look for splice sites, and that's what you're going to report in your paper. If you want to go ahead and tell me the sequence that comes up in between your splice sites, that's great. Not requiring it, that's a little extra work and we're limited on time, but at least come up with reasonable places you think it's spliced, and it's going to be, you know, in this area. You know, it might be a little further down, but generally find the handout and find the reasonable splice sites and say, oh, here's one, and then there's going to be one on the other. So go through and identify these just like this. Hopefully you don't have quite so much splicing in your gene. This gene has, if I remember right, 11 exons, so there's a lot of splice sites in this one. And then you kind of, is this one? You have to kind of decide that, and yes, it was. I went and looked, and there's one right there, and then here. So these are all your exons, and this is how you would do that. All right, I hope this helps. Do the best you can. This is probably one of the harder pieces of this assignment, but if you just go slice, it's going to tell you where everything is at. And the great thing about it is it also tells you where the transcription start site is. It's going to be up here somewhere. Wherever this one starts is probably where this one starts, or at least you can guess. You look at the criteria for it, and you know it's before the place where the mRNA starts, so you know this is the region that you're splicing. It's not going to be too far ahead of your first thing. So the best maybe a CA somewhere. It could be right there. You could make an argument that this is your transcription start site. Any place there's a CA would be a reasonable one, but then you'd have to also get in your promoter. You have to figure out what your promoter is and things like that. So it's probably not this one, but you could go in and make some arguments. Here's one, but just remember you're gonna have to have your core promoter in there. All right, so work on this one. I'll grade it pretty easy.